Welcome to Online Algebra 2. This is section 7-4, Properties of Logarithms. So our objective in this section is to use the various properties of logarithms. And logarithms and exponents have corresponding properties. So what we're really going to be doing in this section is we're going to be taking logarithms and pulling them apart, and then we're going to be smushing them back together. So we're going to take a bunch of logarithms and put them into one single logarithm, and then we're going to split it up. This is useful for when we have to solve equations with logarithms. And the properties, the way we do this is very similar to the exponent properties. So I'll demonstrate this with the product property of exponents to derive the product property of logarithms. So we have our definition here. So x is going to be this, y is going to be this. So if I use the definition of a logarithm, and we could rearrange this thing, and we can say that the inside of the logarithm is equal to b to the x power. That is the definition of logarithm. And the same thing on this side, that n is equal to b to the y power. Okay, so then let's take these two and multiply them together. And because of this equality rule, we can see that we can just multiply these two together. It would be the same thing, right? M is b to the x, n is b to the y. Multiply them together, we get the same thing on both sides. Now if we use the product property of exponents, right, m times n, same base, we add these exponents together. Okay, now if I go back to a logarithm, right, I'm going to say, okay, my log with a base b is going to be, or sorry, log with a base b of m times n is equal to the exponent. Okay, and then we take this all the way back to the beginning. We can see now my rule for logarithms that the log base b of m times n is equal to x, which is log base b of m, plus y, which is the log base b of n. So this is what is, and we got to this by just using this rule, right? Because we have the same base, we can add exponents together. And because the logarithm, the answers to logarithms are exponents, my properties work fairly similarly. Okay, so we have three properties. I'm not going to. We just went through the product property. I just showed you kind of how that worked. Quotient property and power property work kind of the same way. So the product property says that if you have the log base b of two things multiplied together, you can split it into two logarithms using addition. If you have division, you can split it to two logarithms using subtraction. And this one is probably the most important, the one that we will use the most often. Power to a power. This exponent could come to the front here, and we could have that number times the logarithm, because it's still power to a power. Power to answers to logarithms are exponents. So it's still power to a power. Okay, so let's start using these techniques and put these expressions together into a single logarithm. Now, it only works if the base is the same. Luckily it is. So we see that we have subtraction, which means that in order to put these together into the same logarithm, I'm going to use division. Okay? Don't do this. Over log base 4 of 2. That's something different, okay? Right? When we see this, when we see my property, right, it's only one logarithm on this side. Okay, so it's the log of 32 over 2, which now I can do this division first, which gives me the log base 4 of 16, and the log base 4 of 16 is 2. So I was able to simplify it using this technique when I wasn't able to simplify it before. I could have maybe known what exponent would do this one, right? 1/2. Log base 4 of 2 is 1/2. But this one's a little trickier. It would have been 1.5, but that's kind of hard to figure out. Or, sorry, 2.5. Okay. So next one. The numbers in the front turn into exponents. So this is the log base 2 of x to the 6th plus the log base 2 of y to the 5th. And then I still want to put it together to one exponent or one logarithm. So this addition sign here means that I'm going to multiply those two together. And now I have simplified into a single logarithm. Okay, let's try it again. Try the guided problems. Okay, addition means I'm going to multiply these two together. So this turns into the log base 4, 5x times 3x is 15x squared. And we're not adding them together, right? We're multiplying them, so, x times x is x squared. Here, subtraction means we're going to divide, but don't forget that first this 2 goes to an exponent. So this is log base 4 of 6 squared over 9. 6 squared is 36. Divided by 9 is 4. And the log base 4 of 4 is 1. Okay. So that was condensing, simplifying logarithms into a single logarithm. We can expand a single logarithm to involve the sum or difference of two or more logarithms. So we can do the opposite. Okay, so let's do that. We just do the same properties. Okay, same three properties, except instead of starting on the left and going to the right, we're going to start on the right and go to the left. So this can split into 3 separate logarithms. It has 3 pieces. Okay, so the base is 10. Don't forget, if you don't see the log, if you don't see the word, if you don't see a number down there, that means that there's a base 10. So that would be the log of 4 plus the log of x, because both of these are multiplied together, and they're both kind of in the numerator. Well, they both are in the numerator, so they're both going to have positive exponents, minus the log of y, because it's in the denominator. It's a negative exponent, so we have to subtract it. Next, this can separate it into 2 pieces and maybe simplify a little bit. So let's try it out. Log base 9 of x to the 4th minus the log base 9 of 729. The 4 comes to the front, so it's 4 log base 9 of x minus, well, these two go together pretty nicely. 9 times 9 times 9 is 729. So that means the answer to that is 3. Okay, and now that it's simplified. All right, let's try the guided problems. So you could say, all right, first 250 divided by 37, does that give me anything? No? Okay, so we can just split this into log base 3 of 250 minus the log base 3 of 37. And unfortunately, there's really not anything you can do with that there. B is tricky. Be very careful with B. So we split it into two pieces. The log base 3 of 9 plus the log base 3 of x to the 5th. Okay. Now the 5 comes to the front. Log base 3 of 9 is 2 plus 5 log base 3 of x. Okay. A lot of people would be tempted just to move the 5 to the front. Don't do that unless you have parentheses, unless both of them are raised to the 5th power. Then that changes the meaning a little bit. But if you move the 5 to the front, you would be multiplying both terms by 5, which is clearly not what happens here. Okay. Before we go to the next part, I wanted to add one more thing here. What happens if there was another term in the denominator? So, recall from a minute ago, these two were added together. You might be tempted to say, okay, well, it's y times z. Okay, but that would not be correct. Okay, because both y and z are now in the denominator. So you have two choices. You put a minus like that, because y is a negative exponent, it's in the denominator. Z is a negative exponent, it is in the denominator. Or you can group them. Okay? Now you're multiplying these two together, and now you're saying that both of them are in the denominator, both of them are a negative exponent. So it is these two divided by these two. So again, a subtle difference, but easy to make a mistake. Okay, so you've seen that logarithms have many bases. This key on your calculator, the log key, right? It doesn't have a base there. Now, some of your calculators do. Some calculators have a button that looks like this. Okay. If your calculator does have that, that is great. Then you don't need to use this technique. But some calculators only have two logarithm buttons. They have this button for a log base 10 and this button for a log that we'll talk about in a later section called the natural log. So you might be stuck with only these two bases. Okay? So there's a way to calculate any logarithm you want using something called the change of base formula. And the way the change of base formula works is like this. So if we have the log base b of m, we can make any new base I want. Personally, if I only had a calculator with a log base 10, I would make both of these base 10. Okay? Or maybe something that works with b and m better, but that might be a little bit more work if you're just going to use a calculator. So you can change the base to anything you want, and it turns into the log base c of m, this one, divided by the log base c of b, this one. Two logarithms this time. This is not like the other formula where we're splitting up something. We're making another expression from one term. And the way it works is very simple. Okay. So if you start with the log base b of m equals the log base b of m, if I multiply by the same thing over the same thing, you're multiplying by 1, so you're not changing the expression at all. And then if you look carefully, right, we have log base c of b. This turns into the exponent because of the power rule. Okay, and then this inverse property, b to the log base b of m power, is just simply m. So this all just turns into m. And now we have shown that the base doesn't matter as long as it's the same thing right there. It doesn't matter what you choose for the base. This will always work. Okay. So I don't know what power to raise 81 to give me 27. Something weird. But I could use my calculator, or if I really wanted to, I can change this into something that works better with 27 and 81. Well, I know that the log base 3 of 27 is 3, because 3 times 3 times 3 is 27. And 3 times 3 times 3 times 3 is 81. So my answer is 3 over 4. Okay? So you could use this as well. We could have just put the log of 27 over the log of 81 and use my calculator. Okay? Something like this, where the numbers don't work out well together, is easier just to use your calculator. Log of 36 over the log of 5 gives you about 2.23. Change of base. I can change to any base I want. In the got a problem in part A, maybe I want to do it by hand. Maybe I want to just plug in log base 2 of 32 over the log base 2 of 8. So it is 5 over 3. 2, 4, 8. Yep, that's 5. Okay. Whereas this one, 18 over the log of 4. I don't see a good way that 18 and 4 go together. So I'm just going to plug it into my calculator that way and get about 2.08. Okay. You can also use these properties to help you solve a word problem. Okay. So the pH. pH is a logarithmic expression. So the pH of a substance equals the negative log H plus, where H plus is the concentration of hydrogen ions for household ammonia. Oh, sorry, it's the concentration of hydrogen ions. So H plus sub A for household ammonia is 10 to the negative 11th power. H plus for V for vinegar is 6.3 times 10 to the negative 3rd power. What is the difference in the pH? Okay, so really what they're asking me to do here is to take the two pHs and just combine them together. So let's do that. So my equation right there, negative log of H plus for ammonia. And I'm going to take that and subtract the negative log of H plus for vinegar. Right, there's my equation. Very simple. All right, and you're going to see that we're going to use a couple tricks here to make this problem a little bit easier to solve. Minus turns into a plus. The H plus A is 10 to the negative 11th power plus the log of vinegar is 6.3 times 10 to the negative 3 power. Okay. Is there maybe a nicer way to do this? Let's flip these around. And minus the log of 10 to the negative 11th power. Well, maybe I could use my properties here and take this negative 11 and bring it to the front of this logarithm. So that turns into negative times negative 11 log of 10. That turns into a plus 11. And the log of 10 is actually just 1. So that's good. These are two things multiplied together, so I can separate them using addition. And same technique as I just used previously. Move the negative 3 to the front, and now we get the log of 6.3 minus 3 plus 11. Now, did I have to do all this? I could have just plugged this into my calculator. True, but made this a much simpler expression to sub into my calculator, and to give me my pH is going to be, the difference in pH levels is going to be 8.8. So the trick to this problem was being able to recognize the things that I could do to simplify this problem without just stuffing it all into my calculator. Okay, so that was 7-4, the properties of, before properties of logarithms. Real quick, this one. Expand each logarithm there. That is a good one to think about real quick. That is an exponent. The roots of things can be written as fractional exponents, which makes this 1/2 log base 2 of x, or I've seen it as log base 2 of x over 2. And that is good for 7-4, properties of logarithms.